YouTube. Thanks for visiting. Hope all you are doing well. This is Chandan from the learning field. So in this video, I'll going to discuss two questions from CSIR NET June 2024. Okay, and the topic is Markov chain. So in this 2024, two questions comes in Markov chain section. One is 3 marks and second one is 4.75 marks. That is total 7.75 marks. And the questions in this year in the Markov chains are a little bit different from the regular questions that my point of view. Okay, so watch this lecture very carefully. I think this will be very beneficial for you. I think many of you are already watching, already watch actually these questions, because this is something 2024 and this is 2025. But I actually record this video for a reason, because I need these questions a little bit different. So let read the question first, and after when I'll solve, then I'll discuss. So let Xn be a homogeneous Markov chain with the state space 0, 1, 2, 3, 4. Transition probability matrix TPM is given. Let alpha denote the probability starting with the state 4. 10 will eventually get absorbed in closed class 0, 3. Then what is the value of alpha? So these types of questions, I think, generally not asked before in session net. So what it says in the question, let alpha denote the probability starting with state 4 and the chain eventually get absorbed in the closed class 0, 3. So that means we start from a state 4 and going to either 0 state or 3 state, and whether it whatever the time was, if the Markov chain goes to, or process probability goes to 3, then stuck there, or 3 then stuck there, or cannot leave actually 0 state or 3 state. From which state? From 4 state. So from 4 state I can go from this path 4 0, then sorry 4, then any other probability we can may visit like that 4 1 2, and if I can achieve 0, then this will stop here. Okay, otherwise suppose 4 then 3, then stop here. If it arrives 3, then stop here, and we have to find these types of probabilities, and we have to find total probability. Then suppose 4, then 2, then 1, then we get in 3 and stop here. We have to stop here. So this probability we have to calculate this process and find the probability. Now this is the main thing. We have to understand this thing, what we have to find. Okay. Now if I said already that we can solve the questions of Markov chain, most of the questions by drawing the directed graph. Here, these questions we actually can a little bit travel to solve by the directed graph, but I will just give you an idea that how to approach these questions by directed graph. I know this video may a little bit longer. My motto is to give the proper concept. Okay, so watch this video with an a little bit of patience. Okay, so I made this video is something long, but I try to give an approaches that how can you solve this question in this directed graph concept. Fine. So this is the suppose directed graphs. Now 0 to 0 probability is 1 by 4, and 0 to 3 probability, this is 3 by 4. Fine. Then 1 to 1, only one probability there has, this is completely 1. Then 2 to 0, this probability is 2 to 0, 1 by 3. 2 to 1, 2 by 3, end. Then 3 to 0, 3 to 0, this probability is 3 by 4, and 3 to 3, this probability is 1 by 4. Now 4 to 0 we have probability 1 by 8. 4 to 1 we have probability 4 to 1 we have probability 1 by 8. 4 to 2 we have probability 1 by 2. 4 to 3 1 by 8, and 4 to 4, this is also 1 by 8. Now we have to start from 4. Suppose, what is the alpha? You have to understand alpha is the probability that eventually enter the state, the closed class, actually closed class 03, and given probability is x0 equal to 4. We have to find this probability. This is the value of alpha. And let fi be fi the probability starting from state I, okay, of eventually hitting h hitting this closed class 0 or 3. Now what is alpha then? Then alpha means actually we have to find that, suppose this is fi, f of 4. So we have to find this alpha equal to f of 4, because it starts from 4 step and arrive either 0 state and 3 step and stuck here. Now if we see this problem here, if this one state actually is an absorbing state, we can say from here also, because we already tell that in my probability lectures, if we get in general the diagonal element equal to 1 and other probabilities are 0, then we can say generally this is absorbing state. Fine. But the converse is not true. Or in case of that aperiodic case also, if f11 or p, suppose I equal to 1, then this is, we call that I is absorbing. Fine. Now here f1 equal to, or p11 equal to 1, therefore this what f1 is absorbing, therefore this f1 cannot contribute cannot contribute to the closed class 03. That means that probability we have to find this f1 cannot contribute. Fine. So that means the contribution of f1 is 0 here in this case. Fine. Listen very carefully. This you have to understand this. Okay. You have to understand this. Just the solving the first problem is not a big deal. Okay. So this is the main funda. So now to find f4, the mathematical formula that f4 you have to find that, how can we find summation like f I and p I. That means probability, that f4 means what? That f4 means uh, probability of starting from state 4 and eventually hitting in 0 and 3. But it may not be in one step, it may be in that step. So this is that probability that in the TPM has. Okay. Now, so what is the like formula of this f4? So that means f4 means this. Now if first find f0, f1 is 0, we already get. So now what is f0? f0 from the table, from this f0 means what? See, f0 is contributing on this 0 to 0. Just a second. So 0 to 0 and 0 to 3. So this 0 state contributing in only f0 and f3. That means this, from the 0 step we can get 0 to 0 and 0 to 3. That means this actually hit the 0 3 class. from 1 to it hits the class 0 or 3. Sorry, from 0. From 0 it hits the 0 and 3 class. That means what is the value of F0? F0 is directly 1, and similarly F3 value is also 1, because these two are forming the, see here you can also see that F00 plus F30 equal to 1, and F30 and F33 equal to 1. And also these are the own class, na, because 3 and 0 are in this class, this own class, so that means their complete probability is 1. Now so F0, F3, we have F1 also. Now what is the value of F2? So you can find here that, see, F2 means F2 goes to 0, F2 goes to 1, and F2 goes to no another this. And this one contribution is 0 because 1 is another absorbing state, 1 is not belongs to this 0 and 3. So that means what is the value of F2? The F2 value is, see from here, this value is 1 by 3, 1 by 3, and this is F1 means 1. So F1 by 3 means, what is this? F3 means actually we have 1 into 1 by 3 plus F1's contribution is 0. So that means we get here 1 by 3. Understand or not? See, there is no probability in this row, in F2th row. Only we have this 2 to 0 and 2 to 1, but 1 is not, here we can go from this 2 is 1 by 3 and 2 by 3, but this 2 by 3 corresponds to one state, but one state is not included in the 0 state closed class, fine. So that's why this contribution is 0. So this is 1 by 3. Now we have to find actually F4, that is equal to alpha. So F4 means we have to find F1 into that probability means 1, P1 or like that. So I just say this is not the formula, I just want to say this, okay? This is not any formula. Just I want to say that you have to understand, you have understand clearly, okay? So F1 means what? F1 means, now we comes to the next row, that is in this row, that means 4 to 0 in 1 by 8 probability. So 4 to 0 means 1 by 8 probability in, and F0 ka value is what? F0 ka value is 1, because this gives complete contribution. Then this 1 by 8 into F2. F2 value is what? F1 value. 1 by 8 into F1 value is 0. Then 1 by 2. Then 1 by 2 into what? 1 by 2 into F2. F2 value is what? 1 by 3, that we already find. Then F1 by F3. F3 into, this is also gives 1 because F3 comes to F3. See, F1, F0 and F3, these are own class, na? So these probabilities are 1 and 1. Fine. And here also F4 to 4, one loop also present. So 1 by 4, 1 by 8 actually. So 1 by 8 into this probability is also will have 1, because this in this loop OTF, this 4 to 4 loop, and this gives one contribution 4 to 4. So this is also 1. Like you think like that, okay? This is not means that I say this is not that proper words, but you have to think like that. So F4 means what? This is also, sorry, F4, we don't know this probability, not 1. This is because of we have to find this. So that means what? 1 by 4 plus 1 by 4, 1 by 8 means 2 by 8 means 1 by 4 plus this gives 1 by 6, and this gives 4 minus 1 by 8. So 7 by 8, F4 means alpha we can put. So that means alpha equal to what? Alpha equal to, here we get uh, 12, 12, 3 plus 2, 5 upon 12 into 8 upon 7. So 4 3s are 4 2s are. That means 10 by 21. So this is the answer of this question. Fine. 10 by 21. I think you will understand this problem, because this is something a little bit different kind of problem that generally asked in that Markov chain questions in CSIR net. Okay. Next question. So this question is given that TPM is given for a homogeneous Markov chain 0, 1, 2, 3 is this. What is the following step? Now, I more add one thing in this question. How you solve this thing that problem in directed graph from directed graph. See, 0 first starts with 0. So 0 to 0 we get in 1 by 4. Then contribution is 0 to 3. So this is the contribution. So 1 by 4 into 1 by into 1 because plus 1 by 3 into 1. So this is the total contribution and which gives you 1. So that means F0, this contribution is 1. Similarly for F1, F2 and like that. But this is little bit complex when you compute actually for F4 or F2 or other steps. So that's why go with this like case. It's easy for calculation. Okay. Next. So this is the TPM. Now we first draw the directed graph 0, 1, 2, 3. 0, 1, 2, 3. So 0 to 0 we get 0 to 0 1 by 4, 0 to 1 in 3 by 4, then 0 to 1 to 0, 1 to 0 in complete 1, 2 to 0, 2 to 0 in 2 by 3, 2 to 2, 2 to 2, 1 by 3 and 3 to 2, 3 to 2 probability is 2 by 5 and 3 3 self loop 3 by 5. Now it says that 0 is positive recurrent. Positive recurrent means non-null recurrent or non-null persistent. So to calculate this non-null persistent, you have to calculate what? Mu jj. What is it? Mean jj means mean recurrent time. And we know that if mu jj is finite, then we say that it is non-null persistent. See my lecture number, I think Markov chain lecture number 5 or 4. In my lecture series of Markov chain, I already discussed these things very nicely. So you can check these lectures or complete lecture series of Markov chain. Non-null persistent. Okay. And if mu j equal to infinity, then this is called null persistent. And persistent means recurrent. Okay. Persistent means recurrent. So, and this is what is the formula to find this? This is equal to summation n equal to 0 to infinity in fii to the power n. And what is fii then? Fii is first time passage probability. What is the first time passage probability? You see my lectures, okay, of Markov chain. I actually discuss these things. I explain this very easy way so that you can understand. That's why like 35,000 people gives watch my Markov chain playlist. Okay, 35,000 playlist people. So it's not like a very less number. It's a very huge number for me. So now, without calculating this series, how can we solve this problem? Fine. So I already discussed in my Markov chain playlist. You have two Brahmastra in your hand actually. What is that? A finite Markov chain. I already discussed that if a Markov chain is finite, okay, and irreducible, then this finite plus irreducible Markov chain has recurrent RENT recurrent. And number two is what? Number two is if the class or Markov chain is closed, class communicating. closed plus communicating, then this is also gives you recurrent chain. Fine. So also gives you recurrent chain. And if the actually this is recurrent plus closed plus communicating and finite, what is my cursor going? Where is my cursor? I didn't see my cursor actually. Just a second. Then this implies actually recurrent finite plus irreducible chain implies finite, and this is also positive recurrent in case of finite chain. Okay, positive recurrent or non-null persistent. Fine. So it is an theoretical concept then you can apply in this problem. Okay, otherwise you have to calculate the passage probability. I just give you the idea that how can you that do not find this series and solve the question. Fine. So it says that state 1 is aperiodic and positive recurrent. So aperiodic means aperiodic obviously. See, and how can we check first that state 1 is aperiodic? If the state is aperiodic or not. So D1 we have to find. D1 we have to find. So G1 means GCD of how many step 1 to 1 possible? 1, 2, 2 step में possible है. Then 1, 0 में loop and 3. So 3 step में possible and so on. So this is 1. So that means GCD of 1. That means this is an aperiodic. Obviously the statement is correct. And one more thing is that if we see this graph, so 0 and 1. Okay, 0 and 1, if we see that P00 plus P01, this is equal to 1, and P10 plus P11, this is equal to also 1. And if these two happen, then that means 0 and 1 are closed class, formed a closed class. Also, you can see from the directed graph that they are also communicating. That means if they are closed and communicating, then that means they are recurrent. That means 0 state and 1 state are obviously recurrent. And since is a positive finite Markov chain, then for finite Markov chain, recurrent directly implies positive recurrent. You don't be bothered. Okay, positive recurrent. We can directly say from the theorem. Okay, if you don't understand, then go to my lectures where I explain very clearly by taking the examples, by calculating mu, JJ also, and direct by theoretically. Okay, so you have if you have any means what confusion, then you can go to lectures and watch the examples that I understand explained. Okay, that means this option 4 3 is correct. Now what is the case of what aperiodic? State 2 is aperiodic or not? You have to check. See, first though you have to check whether state 2 is recurrent or not, because this null recurrent or positive recurrent is a kind of recurrence relation, or you can say recurrent. But if the state is not recurrent, then there is no questions of null or positive. So see, if we leave 2 from this root, if we leave 2, then there is no path to come back to. That means what? 2 is transient state. If 2 is transient state, that means ये recurrence का कोई question ही नहीं उठता. ठीक है, ये question directly falls from here. Don't be check also aperiodicity or null recurrency or to don't have to find the mean recurrent time. Fine. अगर state recurrent होगा तो ही फर्दर पॉजिटिव रिकरेंट और नल रिकरेंट होगा ना. अगर स्टेट रिकरेंट ही नहीं है तो नल रिकरेंट का कोई क्वेश्चन ही सवाल नहीं होता है, मीन्स आता है. सिमिलरली in state 2, see, if we leave state 3, then there is no path to come back in state 3. That means state 3 is transient. True option. State 0 is positive recurrent. So also already we have find that state 1 and 0 are form in closed communicating class, and one theorem I also discuss that I in my lecture is that all states, ये जो theorem है, all states in a communicating class, in a closed communicating class have same classification, have same classification. ओके, दैट मीन्स क्या है, ये देखो, अगर स्टेट टू, सॉरी स्टेट जीरो, स्टेट वन रिकरेंट है तो वन भी रिकरेंट है एंड पॉजिटिव रिकरेंट ही है डायरेक्टली। ये स्टेटमेंट वन एंड थ्री एक दूसरे को इंप्लाई करेगा, क्योंकि ए एक एंड जीरो दोनों ही एक क्लोज क्लास फॉर्म कर रहा है, मीन्स कम्युनिकेटिंग क्लास। ठीक है, सो फ्रॉम दैट पॉइंट ऑफ व्यू, अगर तुम सपोज एक क्वेश्चन ट्रू किया है, एक ऑप्शन ये नहीं किया है, तो इट्स fault of you. Okay, so these two questions are, I think, something a little bit different. Means these questions is like regular type, but the first question is not like very regular type question that asks in CSIR net Markov chain portion. So this is explanation of these two questions. I think this video is very helpful for you, for your preparation, for your exam. If this video is helpful, if these solutions or method is helpful for you, then obviously give a like to this video, leave a comment in the comment section below, and let's see, let's meet in another video. Thank you, bye.